So in this video, I want to talk about how to recreate the analysis that we use in this paper as part of our series of systematic reviews. So at the end of this paper, there is code that we use in R to create the figures that are in this paper. I've taken that code and I've just put it in a Word document, and I'm just going to copy and paste between Word and R. There are more elegant ways to do that, and you can use RStudio, but I'm just going to use R. First of all, the code assumes that you have the package. So let's just go to R, and if you go up into packages, you have to check that you have the package. And if I look at Package Manager in mine, you'll notice that if I scroll down, I already have the package Meta, and so I don't have to install it. If you haven't got it, then you have to install it. So you can use a package installer, and I use a Mac, but you can find the same sort of information in a PC. So I'm going to enter this bit of code, not that bit of code, just going to go back to Word, and I'm going to enter this bit of code. Just press respond, and it says that I've actually already got the package, which we already knew because I had it checked off. So the next part that we need to do is check where my data set is, and I'm going to do that by getting my work directory. And you'll see that this says paper 6, so I know that that's where my data is. If you're make sure when you're using R that you're pointing to wherever the data set is. Now, with respect to the paper, the data are included, but you'd have to create a file of your own and save that somewhere. And the way that we have the code working is that the data set is called example.csv. So you'll need to save it as a CSV file called example. Or if you don't, you just need to modify this piece of code here and call it whatever you want to call it. However, this code is written for bringing in a CSV file. So I'm just going to copy and paste. This piece of code is going to read a CSV file. It's assuming the separator is a comma. It's saying that I have headings. If you don't have headings, then this would be false. And it's saying that the NA string is a space. And then it wants to call the data set DAT. So I'm going to pull it in. It's called example, but when it's in R, it's going to be called DAT, D-A-T. And so nothing happened, which indicates in R that there is everything's fine, usually because R, it's okay unless you get an error. And if I type in ls, what it's going to do is give me a list of the data set of what the objects I have in R, and you'll see that one of them is DAT. And if I type in summary DAT, it's going to give me a summary of that data set, so you can see there that's what I have. If I type in str, that's going to give me information about the structure of that data set. I've got 13 observations with 9 variables. If I type in fix DAT, you'll see I'll get the data set. So a little bit of information on how to have a look at your data. So the next thing I want to do is I'm going to create an object called OR meta, which is going to be a meta-analysis with the summary measure being the odds ratio. You can see here that I'm using meta bin, which is meta for binary, and the first 4 objects, the event E, NE, event C, and C, are the columns, are the names of the columns that represent my data. So those pieces came in with the example data set, and if you were to give those columns something different, then there you would need to modify that piece of code. And here I've got an option for the odds ratio. So what I'm going to do is run that piece of code, and because I'm creating an object, there isn't actually going to be any output when I do that. We'll see the output later. So first let's enter that, and we get nothing, which is usually a good sign. Going back to R, the next piece of code, you'll notice that it's almost exactly the same, but now I've changed it to this SM. What's the summary measure? Now it's a risk ratio. This is something that comes with the package, and we can have a look at that quickly at the end. So now I'm going to call this object RR meta. I'm going to paste that in, and again, I don't get any error, which is very nice. So if I look in LS, which gives me the list of objects that I have, you'll see that I have now an object that's called OR meta and RR meta. And actually, you'll see I had it before because I ran this code before I started to check the code was working. I ran it before we started the video. So now let's have a look at the output. So there's two ways to look at the output. One is to just type in OR meta, and you'll see this is what we've got. We've got the output. What we have is the odds ratio from each study, the number of studies, and then we have the summary effect measure from the fixed effects model, the summary effect measure from the random effects measure model, and the quantities of heterogeneity, and also the test for heterogeneity. And you can read the paper to find out what they are. So the other way to do it, which is the way that we did in the paper, was to use the function summary. So summary OR meta. And you can see this time I just get the summary. I don't get this additional information, and either of these is fine. It's the same output, just one is abbreviated. And I can do the same thing for the meta-analysis using the risk ratio as the effect measure. Again, I get an output and I get a slightly different number, and it's not surprising that the risk ratio is closer to the null than the odds ratio, because that data, those two effect sizes always have that relationship. So now let's try and get the forest plot, and you'll see here I'm now using the function forest, and you can see I'm telling it which object to use, and use the object that uses the odds ratio. I've got this combined R equals true, so that's the random effects, and then combined F equals true, that's the fixed effect. I'm asking it to plot those. So we'll just copy that over to R. And now I'm going to get my output, and I'm just going to resize it so that it'll all fit. And in this example, you can see that they are so close that on the graph, the line for the odds ratio for the fixed effect model and the random effects model are virtually on top of each other. As you can see here, these 0.48. If I just wanted to plot one of them, I could just put a false in here. Let's just say I just want to plot the random effect, and I type that in. And you'll see this time that I haven't got the fixed effect included. Going back to Word, I can do exactly the same thing for the risk ratio as the measure of association. And it just gives me a different number. And you can see this time the fixed effects and the random effects are slightly different, and you can see two lines on this plot. And you can read the paper as to why they might be slightly different. So then the other things that we like to do, of course, is we like to run a funnel plot, and the function that we use for the funnel plot is funnel. And you see we have the funnel plots, and again you can read the paper about how they could be interpreted, and there are actually a variety of different ways that you can do the funnel plot. And last but not least, the paper itself has a influence analysis using meta-inf, and I'm just going to copy that. Actually I won't, because it's not going to copy well. I think I can do it this way. And you'll see this is the influence analysis, looking at the impact of removing each study from the meta-analysis, and you can see, interpret that based on what's written at the papers. So that's a very brief discussion about how to reproduce the analysis in R. One thing that is helpful is to know what the particular functions are in a R package, and we won't go over all of them, but if we go down to meta bin, you can see here that this is all the code, and many of these we have not used. The only ones we used was these, how to signify the actual rows of data, and also we used these, which discussed whether we wanted to have the fixed effect or the random effect. Notice that they have true, and I summarized that down to T. You don't have to do that. You could type in true. And then further down here, you'll see that those functions are actually described. So for example, here, comb fixed, a logical, indicating whether the fixed effect meta-analysis should be conducted. And so you can try to get a little bit more interpretation of what these mean by scrolling down here. Notice here, this is another one that we used, SM, a character string indicating which summary measure you would like to use, and you see that we used the risk ratio or the odds ratio, but there are other options that we could have used.